Hello everyone, this is Dr. Nak, and today we're going to learn how to solve radical equations. Fun, fun, fun. So first what we're going to do is we're going to learn how to solve a radical equation with one radical. And guess what? In our next topic, it's going to be how to solve a radical equation with more than one radical, but we'll get there in a second. Or maybe I should say in a few minutes. Anyways, here are the steps. So step number 1, given a radical equation, isolate the radical on one side of the equation. Step 2, raise both sides of the equation to the power of the index. Meaning, if you're giving a cube root, you're going to raise both sides by the power of 3. Anyway, step 3, solve the new equation, and finally, check your answers. So let's start doing some examples. Example 1, solve square root of 9x minus 2 plus 1 equals to 0. Alright, we got this. So step 1, we're going to have to isolate the radical on one side, so which means that maybe we should bring the 1 on the right hand side by subtracting 1. So I'm just going to go minus 1, minus 1. Then what do we have? Square root of 9x minus 2 equals to negative 1. Next step is raise both sides of the equation to the power of the index, meaning since we're given the square root, we need to get rid of that square root in order for us to solve for x. So what we need to do is raise both sides by the power of 2 because we're given the square root. So here's my step. Next step, I'm going to raise both sides to the second power. Then what do we get? Square root and 2 is going to cancel each other out. So we got 9x minus 2 equals to negative 1 whole quantity squared is 1. And we could solve this new equation easily by, let's go with adding the 2 first. Then here you're going to have 9x equals to 3 dividing by 9. And what do we get? We're going to have x equals to 1/3. Alright, do not get too excited yet. So what we need to do is we need to check this solution. So checking means that you're going to plug your proposed solution, in our case 1/3, into the given equation. So let's check. So question is 9 times 1/3 minus 2 plus 1, is it going to equal to 0? This is what we need to be asking. So let's check. So 9 times 1/3, that's going to give us 3 minus 2. And then plus 1. And here you're going to have square root of 1 plus 1. Well, isn't that equal to 2, which does not equal to 0. So guess what? This tells us that our proposed solution fails, which means that the answer is no solution for this particular problem. So I'm going to write it as no solution, or the notation for that with a curly bracket with nothing in it. Alright, so I'm just gonna box this. Now, let's go back to, let me see where that step go. This step right here. So this step tells you that we got square root of 9x minus 2 equals to negative 1. Square root equals to negative 1. Could the output of the square root value, could it ever be negative? Answer is no. So if you realize that, then you didn't have to go through everything. You could just answer it as no solution and be done with the problem. But in case you didn't see that, what we did was we just solved everything and we checked our answer and it did not satisfy the given equation, so our answer is still going to be no solution. Let's do another example. Solve square root of x minus 1 plus 1 equals x. Alright, so step 1, we need to isolate a radical. So what we need to do is maybe subtract 1 from both sides. Then what do we got? We got square root of x minus 1 equals to x minus 1. Alright, now we need to get rid of that square root. So what power do we need to raise the square root by? Well, that's power of 2. So I'm going to raise both sides by 2. Now be careful on the next step. X minus 1 is a whole quantity. So if you're going to square that, you're going to have to square the whole entire thing together. Please note that x minus 1 whole quantity squared does not equal to x squared minus the 1 squared, by the way. It means that you need to multiply the whole quantity x minus 1 twice. But anyways, let's keep going. So the square root and the power of 2 is going to cancel each other out. So we're left with x minus 1 equals, now this side is going to be x minus 1 times x minus 1. So we're going to have to FOIL. So let's keep going. So if I FOIL this, we get x squared minus x plus 1. So x minus 1 equals x squared minus 2x and then plus 1. You're like, oh my gosh, what's going on here? All right, we got this. What we need to do is we're trying to solve for x. So let's bring everyone on the right hand side by subtracting both sides by x. And then add the 1. Let's do them step by step. Let's just move the x first. So then here you're going to have negative 1 equals x squared. Now you're going to have minus 2x minus x. So we're going to have minus 3x, then plus 1. All right, now I'm going to add 1 to both sides. Then what we're going to get is 0 equals x squared minus 3x and then plus 2. Alright, so now what we need to do is we need to solve this. So here comes the factoring skills. We're going to be able to factor this out. So let me see. So we got 0 equals, alright, let's see what's going to go in here. X, sign better be negative, 2 and a 1. Would that work? Yes, it would work. So that implies that either x minus 2 is 0 or x minus 1 is 0. So that implies that either x is 2 or x is 1. Okay, so we cannot relax yet because we still need to check our proposed solutions. So let's do it. So check. When x equals to 2, we're going to plug that 2 back into our original equation to see if it's going to satisfy the equation. So what we're going to get is square root of 2 minus 1 plus 1. Is it going to equal to 2? This is what we need to check. So let's compute the left-hand side of it. And so here we get square root of 2 minus 1 is square root of 1 plus 1. Last time I checked, that's 2, which equals to 2, so it checks. So therefore, x equals to 2 is going to be a solution. Now let's check when x equals to 1. All right, we're going to do the same thing. Plug this value back into our original equation. So we got 1 minus 1 plus 1. Is it going to equal to 1? All right, so that's the question that you need to be asking. So let's compute the left-hand side. So we got square root of 0 plus 1. Square root of 0 is 0, so we have 1 on the left-hand side, which matches up with the right-hand side. So therefore, remember the 3 triangle dots means therefore, our solution set is 2 and 1. So we get to keep both of our proposed solutions this time. Okay, now let's take a look at solve cube root of 5x plus 1 plus 8 equals to 4. So again, what we need to do is first we need to isolate a radical. So let's bring that 8 on the right hand side by subtracting by 8. So then we get cube root of 5x plus 1 equals to negative 4. Now notice that since we're given the cube root, yes, the outcome of the cube root can be negative. So you cannot just sit there and say, there's no solution. No, if this was a square root or fourth root, and then that's going to equal to a negative number, then immediately there's no solution. But here we're going to have to keep going. So let's do it. So how am I going to get rid of that cube root? So we're going to have to raise both sides by the power of 3. Okay, so then we're going to have 5x plus 1 equals negative 4 to the third, which is same thing as negative 64. All right, now we're going to solve this. Minus 1, So we get 5x equals negative 65. All right, now let's divide it by 5, dividing by 5. So we're gonna have x equals, what is that? Negative 65 divided by 5, is that negative 13? All right, so then that's gonna be our proposed solution. Now we have to check. All right, so check when x equals to negative 13. All right, so we're gonna go back to the original equation just like what we did before. So we're gonna have to check, is cube root of 5 times the negative 13 plus 1 and then plus 8, that's it gonna equal to 4. So let's check the left hand side. So the left hand side is gonna look like cube root of, okay, 5 times negative 13 is negative 65 plus 1 and then plus 8. Let's keep going. So here you're gonna have a cube root of negative 64 plus 8. So this is what? Negative 64 cube rooted would be negative 4 and then plus 8, which gives us 4 and yes, which checks with our right hand side numerical value of 4. So in this case, we can keep the negative 13 as a solution set. So we say that therefore our solution set is negative 13. How you guys doing up to here? Hopefully you're kind of getting the hang of it. So let's take a look at another one. Let's try 3 times the square root of 3y minus 5 minus 8 equals to 4. So again, we're gonna have to isolate the radicals. So let's first add the 8 on both sides. So then what do we get? We have 3 times the square root of 3y minus 5 equals to 12. All right, but the thing is, square root is not isolated yet, so that little 3 is in the way. So how do I get rid of that? Will be dividing by 3. So I'm going to divide it by 3 on both sides now to get square root of 3y minus 5 equals to 4. Okay, so let's keep going from here. I need to get rid of that square root, so we need to raise both sides by power of 2. Then we have 3y minus 5 equals to 16. All right, so then add 5, we got 3y equals to 21. Dividing that by 3, then we're gonna have y equals to, what is that, 7. Okay, so now we check. So is 3 times the square root of 3 times 7 minus 5 minus 8, is that gonna equal to 4? All right, so again, let's start computing the left hand side. So here what we're gonna get is 3 times the square root 21 minus 5 and then minus 8. Then here you're gonna have 3 times the square root of 16 minus 8, which is gonna give us 3 times 4 minus 8. What is that? 12 minus 8, which is gonna give us 4, which matches up with the right hand side. So therefore our solution set in this case would be 7, and that's gonna be our answer. I feel that you're getting a little bit comfortable with solving radical equations with one radical. So let's take a look at what's going to happen if we're given 2 radicals in one equation. Let's take a look at example 5. Solve cube root of 4x minus 3 equals cube root of 3x plus 2. So notice that this is an equation involving 2 radicals. So pretty much all you have to do is this: isolate one radical on one side and then follow the same procedure as we did before. So in this case, one radical is already on the left, or the right as well, so we're ready to go. So first, we need to get rid of that cube root. So what do we need to do? Raise both sides by power of 3. So then we're gonna get 4x minus 3 equals 3x plus 2. Easy peasy. Now, we're gonna solve for x, so let's bring the 3x on the left hand side by subtracting it. So then here you're gonna have x minus 3 equals to 2 plus 3 plus 3. So it looks like our proposed solution is x equals to 5. All right, now the moment that we have been waiting for. Let's check. All right, when x equals to 5 is cube root of 4 times 5 minus 3. Is that going to equal to the cube root of 3 times 5 plus 2? All right, so it looks like we're going to have to compute both sides now. So let's start with the left-hand side. So the left-hand side, what do we get? We got cube root of 20 minus 3, which is cube root of, what is that, 17? All right, so now let's compute the right-hand side. Then you're going to have a cube root of 15 plus 2. So we got cube root of 17. Looking good because look, left-hand side equals to the right-hand side, so it checks. So therefore, our solution set is going to be 5. Now let's try this one. Solve square root of x plus 1 equals to square root of x plus 9. All right, so now we got 2 square roots going on, but we do have one radical on the right-hand side. So we're good to go. So let's just do our same business. So first, I want to get rid of this square root. So what I need to do is raise this guy by the power of 2. So guess what? Whatever I do to the right, I need to do the same thing on the left. Again, be careful. Square root of x plus 1, you need to square the whole quantity of it. So in this case, what we're going to get is square root of x plus 1 times the square root of x plus 1 equals to, now square root of x plus 9 to the second power is just going to be plain old x plus 9. Now on the left hand side, we're going to have to FOIL. So we got square root of x times the square root of x, which is going to be x, and then plus the square root of x plus the square root of x plus 1 equals to x plus 9. So it looks like we're going to have x plus 2 square root of x plus 1 equals x plus 9. Do not panic. I know it looks ugly, but we got this. So let's first subtract both sides by x and see what's going to happen. So what do we got left over? We got 2 square root of x plus 1 equals to 9. So let's bring the 1 on the left onto the right hand side by subtracting by 1. Then here what we're going to get is 2 times the square root of x equals to 8. Now we need to isolate that square root, so we need to divide both sides by 2. So then what do we got? We got square root of x equals to 4. All right, now what? We're solving for x, so we still got to get rid of that square root by raising both sides by 2. So then here we're going to have x equals 16. So that's going to be our proposed solution, but now we have to check. Since I'm running out of room, I'm going to check on this side. So check x equals to 16. Is it going to satisfy our equation or not? Okay, so let's go. So the square root of 16 plus 1, is it going to equal to the square root of 16 plus 9? All right, so let's compute the left hand side of it. So we got square root of 16, which is 4 and then plus 1 equals to 5. All right, so now let's compute the right hand side. So what do we got? We got the square root of 25, which equals to what? 5. Oh look, it matches up. Yay! So that means that our solution set is going to be 16. And this is going to be our answer. Let's take a look at a problem like this. Solve square root of x minus 2 plus 3 equals square root of 4x plus 1. So step 1, do we have one isolated radical on one side of the equation? Yes, we do. We got the square root of 4x plus 1 being isolated. So let's see what's going to happen. We're going to follow the same procedure. So if I'm going to raise the right hand side by 2, be careful. We're going to have to raise the whole quantity of this by 2. So please note this. I see this all the time. Okay, so note square root of x minus 2 plus 3 whole quantity squared. that does not equal to the square root of x minus 2 squared plus the 3 squared. We talked about that earlier, but so please be careful right there. So what I mean by that is this. So what I just did was I just rewrote the given equation. So this is the common mistake. So I'm going to raise the right hand by 2. Then I see this. You're going to raise each term by 2. But that's an illegal maneuver. So this is do not do this. Okay, so I just wanted to point that out. So now let's go back and tackle the problem. So we squared both sides. Then on the left hand side, it's going to become square root of x minus 2 plus 3 times the square root of x minus 2 and then plus 3 equals to just the 4x plus 1, because the square root and the power of 2 is going to cancel each other out. So on the left hand side, what we need to do is we need to FOIL. Okay, so let's do it. So we got square root of x minus 2 times the square root of x minus 2. So that's just going to give us what? Just x minus 2. And then we're going to have plus 3 times the square root of x minus 2 plus 3 times the square root of x minus 2 plus 9 equals, oh no, I'm running out of room. There. Okay, hopefully you can see that. Okay, so then let's simplify a little bit more. We got x minus 2 plus 6 times the square root of x minus 2. What I just did was I just combined these two together. And then plus 9 equals 4x plus 1. Alright, so do you notice something here? Do you notice that we still got the radical flying around? So guess what? We need to isolate that radical and repeat the whole procedure again. Don't hate, because we got this. So first, let's isolate that square root of x minus 2, maybe on the left hand side. But first, let me see, can I not combine the negative 2 and then plus 9? So let me just simplify a little bit. So we got x plus 6 square root of x minus 2. And then we got plus 9 minus 2, so we got plus 7 equals 4x and then plus 1. Alright, so now I'm going to subtract x from both sides. Then we get 6 times the root x minus 2 plus 7 equals 3x and then plus 1. Alright, minus 7 minus 7. Then looks like we're going to have 6 square root of x minus 2 equals to 3x and then minus 6. Alright, so from this step, let's divide the whole side, both sides by 6. Alright, then here what we're going to get is square root of x minus 2 equals 2. Now, remember this property right here. If I have a minus b over c, this is a over c minus the b over c. So I'm going to split that up. So this is the same thing as 3x over 6 and then minus 6 over 6. So we get square root of x minus 2 equals to x over 2 and then minus 1. Now, do you see that if I divided both sides by 6, we're going to have to deal with that fraction x over 2, which is completely doable, but a lot of you, I know for sure that you don't like the fractions. So if you don't want to deal with it, then just stop at a 6 times the square root of x minus 2 equals to 3x minus 6. So what I mean is, let's just not do it this way. Let's not divide it by 6. Let's just bring this guy straight down. Okay, so let me rewrite. So we got square root of x minus 2 multiplying by 6 equals to 3x minus 6. Okay, so all we need to do is get rid of that square root. So which means what? We're going to have to raise both sides by the power of 2. So in this case, remember, you cannot just raise the square root to the power of 2. If you're going to square the whole thing, you better include that little 6 in there as well. Alright, so then this implies that we're going to have 6 squared times the square root of x minus 2 squared equals to 3x minus 6 times the 3x minus 6. Okay, so here we're going to have 36 times the x minus 2 equals 9x squared. I'm foiling now. 9x squared and then minus 18x, another minus 18x, and then plus 36. Okay, I know it looks really ugly, but we can do it. So here what we're going to get is distributing the 36 to each term. Then we get 36x minus, what the heck is that, 72 equals 9x squared. Now minus, I'm going to combine these two together. So what the heck is that? Minus 36x and then plus 36. Okay? So now, what the heck are we going to do? Let's bring everyone on the right hand side and set the left hand side equal to 0. So let's go with minus 36x minus 36x. Alright, then what do we get? Minus 72 equals 9x squared and then minus 72x and then plus 36. Okay, adding the 72. Add that 72. Okay, then what are we going to get over here? So we get 0 equals 9x squared minus 72x, and then what the heck is that, plus 108? Alright, we got this. Okay, so now what we need to do is, guess what? We factor. So since I'm running out of room, let me go into the next page. So let me just copy and paste what we had before. So what do we had before? Do we have 0 equals 9x squared and then minus 72x and then plus 108? Alright, so then from here we must factor. Fun, fun, fun. Alright, so let me see. Do we not have a greatest common factor here? Greatest common factor will be, I think, 9. So here, what I'm going to do is first factor out the GCF, 9, and then rewrite. So this is same thing as x squared and then minus 8x, and then what is that? Plus 12. Okay, so now let's take a look. So we got 0 equals to 9. Now, can we factor this guy? I believe so. I don't know how you learn how to factor, but if you're comfortable using this, I don't know if you saw this thing called the diamond method. You got the 12 on the top, negative 8 on the bottom, and sign better be minus minus, and then you're trying to come up with what times what. It's going to equal to 12, and then what plus what is going to add up to negative 8. So here, what do we get? Maybe 2 and a 6, does that work? Is negative 2 times negative 6, is it 12? Yes. And then negative 2 plus negative 6, is it negative 8? Yes. So then our factored form is now x minus 2 and then x minus 6. All right. I don't know why I put the parentheses way down there, so let me just erase this and then get the parentheses a little bit closer. All right, so what does that mean? So this implies that you can divide both sides by 9 if you want to, but regardless, this implies that either x minus 2 has to go to 0 or x minus 6 has to go to 0. Okay, so that implies that either x is going to be 2 or x is going to be 6. All right, so that's going to be our proposed solution. Now, guess what? We check. All right, so let's go with when x equals to 2. Now, what the heck was our original equation? Our original equation, what does it look like? Let me just recall it. So I think that was square root of, it was at x minus 2 plus 3 equals to the square root of 4x plus 1. Okay, so I'm going to plug it in. So we get square root of 2 minus 2 plus 3. Is that going to equal to the square root of 4 times 2 and then plus 1? All right, computing the left of it. So we're going to have a square root of 0 plus 3, which is 3. And here we get square root of 8 plus 1, which is square root of 9, which gives 3. So it matches up. So therefore, we get to keep x equals to 2 as a solution to this equation. Now let's check when x equals to 6. We're going to do the same thing. So here you're going to have 6 minus 2 plus 3. Is it going to equal to 4 times 6 plus 1 square rooted? Okay, computing the left, we're going to have square root of 4 plus 3, which is 2 plus 3, which gives 5. All right, now on this side, we're going to have 24 plus 1, which is square root of 25, which gives 5. Yes. So that means that we get to keep both of our proposed solutions as a official solution. So I'm going to write it as, therefore, our solution set is going to be 2, 6. And I'm going to box that for the answer. So this problem was the worst case scenario because we had to try to get rid of the radicals twice. But we can do it. Alright, now what I want you to do is just pause the video and try this worst case scenario problem on your own. Alright, let's see what you got. Okay, so I'm going to raise both sides by 2, just like what we did before. This step, be careful. Okay, did you square the whole quantity? I hope so. So now, this implies that we're going to have square root of x minus 1 plus 2 times the square root of x minus 1 plus 2 equals 2x plus 6. Now, we FOIL the left-hand side. Then we're going to have x minus 1 plus 2 times the square root of x minus 1 plus 2 times the square root of x minus 1 plus 4 equals 2x plus 6. So then, let's combine these two guys together. And then I guess we can combine minus 1 and then plus 4. So we get x plus 4 square root of x minus 1 and then plus 3 equals to 2x and then plus 6. Alright, so look at it. We still got that radical, so we need to isolate that radical. So let's subtract x. Then we have 4 square root of x minus 1 plus 3 equals to just x plus 6. Subtracting by 3. So we got 4 square root of x minus 1 equals to x and then plus 3. Alright, so from here, if I divide both sides by 4, do you see that I'm going to have to deal with two fractions on the right? Namely x over 4 and 3 over 4. So what I'm going to do is from this step, I'm going to square both sides to get rid of that square root. So square this, square the whole quantity please. And then what we're going to get here is that we're going to have 4 squared times the square root of x minus 1 squared equals x plus 3 and then another x plus 3. Alright, so then we're going to have 16 times x minus 1 equals x squared plus 3x and then plus 9. I just FOILed it. So then we're going to have a 16x minus 16 equals x squared plus 6x and then plus 9. Alright, so now what did you guys do? Did you subtract 16? Did you bring everyone on the right hand side and making the other side equaling to 0? I hope that's what you did. So I'm going to subtract by 16x on both sides. Then here what we're going to get is negative 16 equals x squared minus 10x plus 9. Alright, almost there. Plus 16 plus 16. Okay, so we're going to have 0 equals x squared and then minus 10x and then plus, what do we get, 25? And now factor time. So we got 0. Alright, so we're going to have xx minus minus 5 and a 5. I believe that works. Alright, so that implies that either x minus 5 equals to 0 or x minus 5 equals to 0. So we just have x equals to 5 as our proposed solution. Alright, now we check. So check. When x equals to 5, is it going to satisfy our equation? So we're going to plug that in. Square root of 5 minus 1 plus 2, is that going to equal to the square root of 2 times 5 plus 6 square rooted? Alright, so this is going to be square root of 4 plus 2, which is 2 plus 2, which is 4. And here what we're going to get is the square root of 10 plus 6, which is square root of 16. That's going to be 4. Hey! Alright, so it matches up. So therefore, our solution set is going to be just 5. How did you do on this problem? Catch your mistakes if you made a mistake somewhere. But hopefully you're understanding this, and I am done torturing you, I think, for today. So great job everyone, and then let me know if you have any questions.